This is section 7.2, adding and subtracting rational expressions. Our rules for adding and subtracting fractions are the same as they are with regular numbers. You're going to add or subtract the numerators. If they have a common denominator, you add or subtract the denominators. Then the denominator remains the same, and then reduce if possible. And remember that everything has to be factored in order to reduce. So let's look at this first problem. 5 over r plus 9 over r. It doesn't matter that my variable is in the bottom. It doesn't matter that I don't know what it is. I just know that it's the same. So I can add across the top, and you keep the denominator the same. So you get 14 over r. And that's not going to simplify at all. Okay, so let's look at this one. My denominator is 6x plus 5 on both of these. It's an addition, so I'm going to add across the top. I'm going to put these in parentheses, not because they matter so much with addition, but because they do with subtraction. Okay, so we have 6x plus 5 here. Okay, when we have a subtraction, if these were being subtracted, I would need to distribute the negative through here. That's why I kept the parentheses. But since this is addition, it doesn't really matter much. So I have 5x plus x, which is 6x. 4 plus 1 is 5. So I have 6x plus 5 over 6x plus 5. Now we're supposed to, factor these before we reduce them. Neither of these factors. So when something doesn't factor and I've looked at it and decided it doesn't, I put it in parentheses. That helps me remember that it has to cancel out completely or it doesn't cancel out at all. Well, I have identical things here and here. When you're dividing something by itself, your answer is 1. It doesn't matter if you're dividing variables. It doesn't matter if anything. If it's the same on the top and the bottom, you've got a 1. Okay, so let's look at a cubed over a squared plus ab plus b squared minus b cubed over a squared plus ab plus b squared. Our denominators are the same. We are subtracting. So this is a cubed minus b cubed over a squared plus ab plus b squared. Now, I really hope you recognize that numerator as a difference of cubes. It's even the same variables. So this factors, the numerator factors as a minus b times a squared plus ab plus b squared. Now, normally, I would be concerned to try to factor this, but I know it doesn't factor, but it's also, I see that it's exactly the same as this. So I'm just going to put that denominator in parentheses. And then you can see that these reduce, and your answer is simply a minus b. Okay, so obviously we're not always going to have the same denominator. So let's see if I can pick up this paper. All right, so we are going to have to talk about how to find a least common denominator, okay? Because just like with regular numbers, we're going to have to rewrite our fractions so that they have the same denominator so we can add or subtract across the top and then reduce at the end. In order to find the LCD when you have variables, you're going to factor each denominator completely, okay? Then the least common denominator is the product of all the different factors from each denominator, which I call each base that's listed, with each factor or base raised to the greatest power that occurs in any denominator. This is one of those things that sounds awful in English, but is pretty easy to do in actuality, okay? So first, we're just going to imagine that these are our denominators and we're asked to find the LCD. Now, each of these is already factored because there's no addition or subtraction in there. Each of these is only multiplication. And what we want to find, first thing we need to do is find the LCD of the numbers. We are looking for the smallest number that divides evenly into both of these. No, I said that wrong. We're looking for the smallest number that both of these divide into. Said that backwards. Okay, so my LCD has to be at least a 24. Whatever your larger number is, your LCD has to be at least that big. Okay, now I'm going to show you a trick, and that this is not in your book whatsoever, about a way to find the LCD between two numbers. What I'm going to do is I'm going to come over here, and I'm going to write 18 and 24 like this. And the first thing I do is, it's kind of like an upside down division sign. I'm going to try to find numbers that divide into both of them. So these are both even numbers, so they're both divisible by 2. I'm going to write a 2 on the outside. Now divide these by 2, and you get a 9 and then a 12. Okay. Now I'm looking for something that divides evenly into both of these, and both of these are divisible by 3. So if I divide that by 3, I get a 3 and a 4. Okay. If we were looking for the greatest common factor, it's right here, because nothing else goes evenly into both 3 and 4. So as soon as we get something where there's nothing in common, you can multiply these two back together to get a 6, and that would be your greatest common factor. We're not looking for greatest common factor, we're looking for LCD. So in this case, we keep going. After you've pulled out everything that divides into both, then you start working on them individually. 3 is divisible by 3. So I divide the 3 by a 3, and I put a 1 here, and I'm just going to bring down the 4 since the 3 doesn't go into 4. And now you can do it again. 4 on the outside, and then that's still a 1. 4 divided by 4 is a 1. You're going to end up with all 1s across the bottom eventually. Your LCD for the number part is going to be 2 times 3 times 3 times 4. You don't worry about the 1s at the bottom. So this is 6 times 12, which is 72. So for the number part, which is actually the hard part of finding the LCD here, it's going to be 72. And now let's deal with the variables. The variables are much easier to deal with than you think. If a base appears, I want to write it down. So there's an X, I'm going to have an X. There's a Y, I'm going to have a Y. There's an X and a Y. Now, how do I decide what exponent to use? You always use the largest exponent. So on my X, I have a 2 here, I have a 4 here. 4 is larger, so that's going to be 4. On my Y's, I have a 3 here, a 5 here. 5 is larger, so I have a 5 there. So that LCD is 72, X to the 4th, Y to the 5th. So let's find the LCD here, K plus 3 and K. First thing to do is to factor as much as possible. Well, this is just K, so there's nothing to factor here. K plus 3 does not factor, so I put it in parentheses. It is a unit. It has to work as a unit. My LCD. I need to write down every base that appears. I have a K. I have a K plus 3. That works as a unit. Okay, so this is not, I don't look at this K to find out what exponent goes here. I only look on where I have simply a K. If that's a first power, that's a first power. The only place I have a K plus 3 is here, and it is an understood first power on the outside as well. So this is your LCD. Okay, so let's check out this one. I have 2y plus 8 and y plus 4. I can factor a 2 out of this one, and I get y plus 4. And then this doesn't factor at all, it works as a unit. So your LCD, you're going to write down every base that appears. I have a 2, I have a y plus 4, and here's a y plus 4, but it's already listed. The largest exponent that appears on a 2 is a 1, so it's a 1 there. The largest exponent that appears on a y plus 4 is also a 1. It does not matter that this appears twice. It only matters that the largest exponent that ever appears is a 1. So this is your LCD.